So I'm honored to introduce Congressman Mike Doyle. He represents Pittsburgh, Pennsylvania, which is home to Carnegie Mellon University. He's a senior member of the Energy and Commerce Committee, where he's a ranking member on the subcommittee on communications and technology, and he's been long been a champion of high technology and education and research. He also founded the House Robotics Caucus in 2007, which has been a great boon to both industry and academia by elevating the visibility of robotics as a critical technology in America's innovation network. Congressman Doyle has been a tireless champion of American innovation and of federal research funding. He's never forgotten the lesson of growing up. I was asked to read this. Growing up in a family of Pittsburgh steel mill workers, which is the constant innovation that is the key to continued economic vitality. So please welcome my Congressman, Mike Doyle.
Thank you very much. Thank you. It's a real pleasure to be here, and I'll just take a couple minutes of your time. All of you here know that innovation is a vital part of our lives, and as a country and a people, we're constantly striving to develop new technology that will give us new tools to achieve new things. Technology and innovation lifts us up, it connects us, and it empowers us. Wireless communication at the advent of smartphones made it possible to be in constant communication with each other almost anywhere on the planet. And look how easy it is now to find almost any product from your couch. I'm not sure good this is good for a healthcare perspective, but have it delivered to your door next day. And how we can type natural language inquiries into search engines and get accurate answers. These are things that most of us couldn't imagine 20 years ago, but today we take all this for granted. And the underlying capabilities that make these extraordinary advances possible is also enabling powerful new tools to help students learn, new businesses to flourish, and new opportunities to be created. But our success in leadership in these areas is not absolute, and we're facing serious competition from other nations looking to take the lead and become the cradle of development for the next generation of breakthrough technologies. Our ability as a nation to maintain our leadership depends on our government's commitment to invest in basic research and to invest in educating and training the next generation of researchers, engineers, and entrepreneurs. Because if we don't do it in this country, it's going to happen somewhere else. Artificial intelligence is one of these exciting and extraordinary new technologies. And I'm proud that researchers and companies in my hometown of Pittsburgh are helping to lead that effort. AI is a technology that holds enormous potential for humankind. But as no one from Pittsburgh needs to be reminded, new technologies can also bring disruptions. Our goal must be to harness the power of AI to bring benefits to all parts of society and to benefit every community. Today, we're here to focus on some of the ways AI is already being utilized for good. And I want to thank the panel, who represent some of the best and brightest minds in the world in AI, as well as agents of positive change in our world. Their work is having a real-world impact while simultaneously advancing the basic science of artificial intelligence. So I know that all of you here today look forward to hearing about the ways in which they're developing and deploying AI to make America and the world a better place. And I thank you for giving me a few minutes to make some comments. Have a great session. Thanks, Jason.
And so this is the fourth in a series of panels that our university has been hosting with respect to artificial intelligence. The first one last year was AI 101, just an introduction of what artificial intelligence is and how these machine learning techniques work. We also had an AI and the future of the workforce. Last January, we also had AI for national defense. And today, we're going to be looking at how can we use artificial intelligence for social good. So what I'm going to do over the next few slides, I'm just going to talk for maybe about 5-10 minutes. I'm going to give you just sort of examples of AI for social good. And so the first example here is healthcare. So this is from the magazine IEEE Spectrum, looking at AI versus doctors. And what it's showing is how well can artificial intelligence techniques work relative to doctors in terms of diagnosing issues that people might have. So on the left side, you can see AI is winning out in some of these cases. On the far right side is where doctors win, and right in the middle is where it's a tie. So you can see, for example, at the very top, breast cancer is roughly a tie with respect to how well artificial intelligence versus humans can actually diagnose things. But you can also see that nail infections, pneumonia, AI techniques actually outperform people too. What I'm going to do next is going to scroll down, and you can also see that the AI is actually doing quite well in a lot of these areas too. So you can see that AI is either tied or better than humans in almost every case except for general diagnoses. Okay? So this is just one example of AI for good. Let me give you another example, which is something I'm sure all of you can relate with, which is traffic and commutes. And so one really cool thing that's been going on in Pittsburgh is that some of these traffic lights that we have actually been converted into intelligent traffic lights that use a lot of sensor data using the magnetic loops under where the cars are, as well as using cameras to try to figure out where are the cars, what is the current traffic, and how do we optimize the traffic. And there was a deployment in 2013, pilot test, and they found out that it actually reduced travel time by 25% by eliminating stops and reducing the wait time, not by actually increasing the speed at which people were traveling. It also reduced emissions by 20% by reducing the stops and idling. And also, people were waiting a lot less, 40% less time waiting at these intersections. So this is also another clear win for artificial intelligence. It was also decentralized, which is also nice too. So you don't require a wholesale adoption. You can actually do this traffic light by traffic light. This has also been commercialized recently too, and it's also becoming more widely deployed in Pittsburgh. Here's a third example that I think is pretty compelling in light of recent events. There's a website, or there's a service called Crisis Text Line. They're looking at how to help people who have suicidal ideations. And the idea here is that you can have an always-on kind of service where if you're feeling any kind of intention to harm yourself, you can do text messages to the service, and then you also might get in touch with counselors and other kinds of services, and might also get converted into a voice call as well too. So they've had over 33 million text messages and 5,300 active rescues where the counselors decided to call the 911 services and send help their way. Now, one thing that's really interesting, and this is a really common kind of theme in these artificial intelligence and machine learning techniques, is once you have large amounts of data, you can actually discover new kinds of things that would never be possible before, and things that are actually counterintuitive as well, too. So, for example, you might think that there's no special day that people are more suicidal or have intention to harm themselves. They found out that Wednesdays are actually the most anxiety-provoking day. I guess that's not really a good sign for today for us. But the other thing that's also hugely counterintuitive is you might think that the words suicide and kill are huge intentions to actually harm yourself. It turns out that they actually aren't, and that the words ibuprofen, Advil, and the crying emoji are about 13 times more stronger signal that you are likely to harm yourself. Right? That's completely counterintuitive and only something you can do once you have large amounts of data. The last example I'm going to show you is from my own research. This is called livelihoods. The basic idea is that we started crawling lots of geotag data from Twitter and Foursquare and other kinds of places, and we're trying to figure out what are the clusters of neighborhoods and where people are going, and can we try to understand the difference between the organic neighborhoods that people envision versus the formal boundaries of the neighborhoods. So if any of you are from New York City, let me give you a concrete example. If you've been to Manhattan, you might know that there's a Little Italy and there's a Chinatown right next to it. Chinatown is actually overtaking Little Italy and actually growing into that. But if you look at the formal boundaries in New York City, it's actually still the same, but the organic boundaries are not. It's clearly been evolving. And so what we were doing is collecting all this data and trying to figure out what the organic boundaries of the neighborhoods were, as well as what are the activities that people do inside of those boundaries too. And let me show you an actual result that we have too. If you're familiar with the Queens and Brooklyn-Queens Expressway, a lot of people in urban planning have said, well, highways cut neighborhoods in half and people don't really cross them. And here you can see in the different colors what our clusters are. It's actually sort of true based on our data. People very rarely cross these highways, obviously for safety reasons too, and there's no easy way to cross them. So here's some more evidence that can also help a lot of these urban planners. Now, why do we care about artificial intelligence? Well, here's some of the potential benefits for it. One is that it has the huge potential for reducing human bias. So how many people here have heard of the story about the Israeli judges doing parole? Okay, so only a few people. So basically what they found is that they were looking at whether they should parole prisoners or not in Israel. And what they found was that prisoners were most likely to be paroled right at breakfast time when they started the meeting and right after lunch, and they were least likely to be paroled right before lunch. Right? So it's a good thing we're giving you food right now. Basically, that means there's some human biases that we're not even aware of, where we might be really grumpy just because we're hungry, and we might be affecting our decision making in subtle ways that we're not even aware of. But this is something that we can actually eliminate with some of these AI technologies. We can also have increased accuracy, which is better than humans in some cases. So I showed you some examples using the medical case. We also have the ability to process really big data, especially sensor streams, where it's just like megabytes and terabytes of data that humans just can't comprehend fast enough. It's also available 24/7, just like the crisis text line that I mentioned. And we can also help prioritize limited resources that we might have. So the crisis text line also does this too, where they're looking at who is most likely to harm themselves, and then they can prioritize actual voice counselors to that, and then also call the 911 services if if they believe that they're actually going to be harmed. But having said that, there's also some challenges for AI as well too. So the first one is data quality. So I'm going to go back to this map I showed you of Pittsburgh, and I just want to toss out a quick question for the audience here. Does anyone notice anything interesting about the clusters that we came up with in our service? Or notice anything interesting about this map here? Well, okay, there are people living in the river, which is definitely not really, which is not going on. It's a really good observation. But you notice that there's a gigantic gap here, right? And it turns out there actually are people living there. In fact, there's a fair number of people living here. This is Pittsburgh Hill District. It was ground zero for jazz musicians in the 20th century, and over 8,000 people that live there, 400 businesses and so on. Construction there actually has decimated a lot of the economic viability of there, and there's also a low socioeconomic status. So the basic issue here is that just because you have data doesn't mean that it's truth, right? So that's something you have to be very careful of, because you might have data, but you might have biases inside of that that don't reflect what reality is. There's other kinds of issues too. So privacy. So some of the same data that we're using can be used for good and for bad purposes. And there's also a lot of the ethical issues too. Like what's going to be happening with jobs? What about dual use technologies? And what about AI bias too? So these challenges are not unique for AI for social good, but these are ones that we're going to be discussing more inside this panel. So what I'm going to do next is I'm going to introduce the three panelists, and then I'm going to have each of them speak for about 5 minutes or so. So our first panelist, Anna Bethke. So she's a data scientist at Intel's Artificial Intelligence Product Group, where she heads their AI for Good efforts. She's been looking at AI in crop growth, looking at how these algorithms can help aid greenhouse operators to achieve high yield while minimizing the use of resources. The second speaker is Fei Fang. So she's an assistant professor at the Institute for Software Research at Carnegie Mellon University. She's been looking at how to use AI techniques for security, sustainability, and mobility. And lastly, we have Jay Chi, is a data science lead at Uptake, which is an industrial AI software company headquartered in Chicago. He's at uptake.org, which is their philanthropic and social innovation arm, and looking at how to help these organizations around the world build data-driven tools and grow their own data science talent. All right, so we're going to start with Anna. Sorry.
Awesome, and yeah, thanks for everyone for coming. This is definitely a topic that's near and dear to my heart, and basically what we're doing at Intel is we're researching and supporting different ways to ensure that AI can be more transparent, less biased, and more accessible. There's a lot of different things that we can do from like a research perspective, an algorithmic perspective, and also the hardware. So it's, that's an area that we have a good synergy through all those different portions. You think of Intel as, well, you make microprocessors, right? But a lot of times, in order to use that hardware, you have to build upon the software and make sure that everybody understands the use cases that can be used for them. The other thing that I want to talk more about is how we're enabling and enhancing the efforts of various social good organizations, providing them with the technology, so both the hardware and the expertise, like our data science or deep learning expertise, to help them positively impact our world. So this is just a smorgasbord of some of the projects that we've been doing, including ones that are past and present. So one of the things with healthcare, we mentioned that it can really help you with that. So this is lung cancer. So basically what you can do is you can help doctors identify where tumors might be located. So this is what's known as a segmentation issue, where you're saying, okay, look at this portion right here, that purple blob. And then the doctor is able to really more quickly see, oh yeah, is this tumor or is this benign? Another thing you can do is protein classification. So this can really help you with drug discovery. Right now it costs a really large amount of money, and I think 10 years or more to be able to figure out, okay, what's the next drug that can help this disease? There's a change in the flu virus. Again, how do we figure out, the vaccination that's going to help the most people as rapidly as possible? And then in terms of Earth, so one of our recent projects is with autonomous greenhouses. How can we use this type of algorithm called reinforcement learning? Basically, that's letting the algorithm learn from its environment as it goes. And so then it can change based upon the weather patterns. It can learn okay, the crops aren't doing so great. Maybe I should try this instead. And also you can use it for disaster response. One of the things that we've really found that's interesting is like the same types of algorithms that can do like the tumor detection can figure out, okay, well, these are the areas that are flooded. These buildings are damaged or destroyed. We should send our first responders to these locations first. So it really helps decrease the time to getting the boots to the ground to the people that really need it the most. And then the last, category that we really focus on is people. So we've been working with the National Center for Missing and Exploited Children to help protect kids. How do we identify those children who might be missing? How do we help our law enforcement say, oh yeah, this kid, that I saw on this call is actually in this database. Maybe something's going on here, and I need to intervene in a different way than what I would do normally. And then finally, one of the other projects, which is really interesting too, is hack harassment. So basically, how do we get people involved to help with internet safety? How do we identify hate speech? How do we identify comments that need to be taken down from a website? And that can help people feel safer online, can help kids as well, because we don't want them accessing certain content. So all of these things are some of the projects that we've been up to, and we're always looking for other ways that we can really support this effort.
Thank you all for coming. I'm Fei Fang, and as Jason mentioned, I'm an AI researcher, and most of my work is motivated by societal challenges in security, sustainability, and mobility. And I guess for the first part, we all know that security is a challenge that's faced by the whole society. Although I guess it might be a better kind of topic for the earlier roundtable session on security and defense, but I think it's still worthwhile to mention here, because indeed, if we can increase the level of security and safety, we can just we are definitely bringing benefit to the society. So we want to protect our critical infrastructures like ports and airports. We want to protect our transportation systems and also prevent cyber intrusions. And in environmental sustainability, we want to protect our forest from illegal logging, protect the wildlife from poaching, and also fisheries from overfishing. All these problems share some similarities, which is we have the law enforcement agencies like the defense agencies versus their opponents. For example, the illegal loggers who want to kind of conduct criminal activities and want to break the laws. And that's where game theory can potentially come in and make an impact. And also in some of these areas, we get data, and that's where machine learning can again be used to predict what the opponents would do, and that's how AI can be used to help address these challenges. And more recently, we also faced evolution in the transportation mode, and here again, we can potentially analyze how would the self-interested agents in this, say, ride-sharing platforms would behave in a way that to their own benefit, and then as a system designer, how should you incentivize all the agents to behave in a way such that it can deliver the most benefit to the society? So for all these challenges, the solution approach that I'm using is to combine machine learning and game theory. And to give you an example, let's start from the security challenges, where how many of you have been to Staten Island Ferry here? Great. So without me mentioning too much about it, you know that Staten Island Ferry is it provides a crucial link between Staten Island and Manhattan, and it carries more than 60,000 passengers a day, and therefore the security of it would be very important. And the US Coast Guard have this small, fast patrol boats equipped with machine guns to move in the water and try to protect it. And here comes the question, how should they patrol? What kind of patrol route should they take every day? And that's where they came to us and asking us, how can we make the best use of our limited defensive resources? Just like we play rock, paper, scissors game, it's not good for you to always play the same action every round. In this patrol defense game, it's definitely not good for the security of the ferry if the U.S. Coast Guard always take the same patrol route every day. And it is very important for the defenders in this case, to randomize, to take a less predictable route and to make the patrol route more dynamic so that it will be harder for the attacker to plan an attack. And that's where we use game theoretic models and try to model the actions available to the defender and attacker and trying to come up with algorithm that can compute the optimal defender strategy. In this case, is a set of patrol routes, each associated with a probability, so that the defender, so that we suggest to the U.S. Coast Guard saying that you can kind of flip a coin every morning and sample a patrol route from this set of strategies or this set of patrol routes according to the probabilities that we provide. And this algorithm has been in use to help the U.S. Coast Guard since April 2013. And of course, I'm not saying that they are kind of following exactly what we are asking them to do, but it at least provides a assistance or a tool that can help them to come up with better patrol routes. And we use a similar idea, this kind of defender attacker game, to protect cyber systems, and also for the problem of wildlife crime, we also try to use the approach to apply to it. But as you may know, the population of key species like tigers, rhinos, and elephants are threatened by the wildlife poachers who place snares and traps on the ground and trying to kind of catch the wildlife. And the conservation agencies all around the world are trying to set up conservation sites and also send well-trained rangers to these areas to catch the snares before the wildlife gets trapped. And here they ask us, how can we help to get the most out of our patrols? And in this case, we know, first of all, we do have data in collaboration with Wildlife Conservation Society and Worldwide Fund for Nature, as well as other NGOs like Panthera and Rimba and El Shepherd. We collect the data about where the patrollers go in the past and where did they find signs of poaching. And we analyze that data together with geospatial features like the distance to the nearest river, distance to the nearest road, and so on and so forth, and build a machine learning model to predict where the poachers would go to place snares. And based on that, keep in mind that where the poachers would go is somewhat dependent on where the poachers would go is somewhat dependent on where the patrollers would go. So it's critical to keep this in mind when we try to design the patrol routes. So that's again where game theory can come in and play a role and make it work together with the machine learning modular when we design the patrol routes. And this system has been deployed in multiple countries, as you can see in Uganda, Malaysia, and China, where the rangers are using our tools to go to places that are predicted to have high poaching threat. And indeed, in Uganda, the rangers go to areas that they didn't go very often before, they found snares, and they are not even aware that this area has high poaching threat before they use this software tool. And we also can assist not only human patrols but also UAV patrols, and we use deep learning techniques to build a system that can detect wildlife and human from the videos taken by the UAVs in near real time, so that we can quickly notify the nearby rangers if there is anything spotted. So with that, I just want to emphasize that AI can be used for security, sustainability, and mobility challenges. Thank you.
Hi, everyone. My name is Jay Chi. I'm coming here from Chicago. I work at a company called Uptake. We are a software company doing predictive analytics for industry. So our vision is a world that works. We are interested in taking data from everything from trains to wind turbines to factories, and using analytics and using software to make those industries work better, more productive, more safe, more reliable, and more secure. And so my primary work involves using machine learning to predict failures on industrial equipment like locomotives and heavy equipment. But my company isn't just interested in making the industrial sector better. We're also interested in making the world better through the social sector. And so our philosophy, this is what we do through our philanthropic and social innovation arm, uptake.org, is giving our genius and our technology. So we are a company that's very specialized in doing data science and in building software that empowers people to use that data science to have insights, to make better decisions, to make decisions more easily. So when we're talking about giving our genius, it's really giving our skills, our talents, our people's ability in data science, in software development, in product, in user experience, research and design, and also leveraging this really powerful technology that we have. So a few of the examples shown on the slide are some of the projects that uptake.org has done. So Reroute is software for anti-trafficking organizations. So we've been working with some organizations at the border of India and Nepal, and they are trying to combat human trafficking. So we've created software that helps them take all of their data and helps them and gives them insights to help them make strategic and operational decisions about how to best deploy their resources. We've also created mobile applications to help their people on the ground make decisions about identifying who might be a victim of human trafficking. Student Union, which I'll talk about a little bit more detail after, is an organization, is an application that we've created with an organization called One Goal to match colleges for students, and we're especially targeting the problem of undermatching for first-generation college students. Autofocus, kind of similar to one of the applications we heard already, is we're using AI to classify images coming from automated camera traps, and this is to help conservation organizations and conservation researchers go through the hours and hours of video they have from these camera traps, identifying where the wildlife is, and this is a huge time saver for them. And then finally, our Data Fellows program is a program that we've created to connect data leaders at social enterprises, at nonprofits, at government agencies to mentorship and resources from Uptake. So it's a 6-month fellowship. We bring in data scientists, and now we're starting a new track in data security to bring in these people from these organizations all around the world. And then we have an ongoing mentorship program where we work with them to work on projects at their own organizations. So I've been involved as a mentor through the program, and I've had the privilege of mentoring some really awesome people from the city of Chicago's data science department, from the New York City Department of Education, also from a technology platform for nonprofits in Australia. We're doing a pretty diverse array of things at uptake.org. I'm going to dive a little bit into Student Union. So the problem we're tackling here is that every year there's more than 400,000 qualified low-income students in the country who aren't attending college. And then on top of that, there's another 200,000 students that are undermatched. They're not going to the colleges that they're qualified for. They're going to colleges that are below their level. And these are conditions that don't set up success for these students. When you think about historically, higher education has traditionally been, higher middle class students who have been attending. The data collected on all of these students reflects that. The tools built from that data reflects that too. And these solutions aren't serving first generation students very well. And first generation students need help. I was actually chatting with somebody at the airport yesterday who turned out to be a first generation college student, and she told me, when she was going and applying for college, it was really difficult because no one in her family had gone to college. People in her community, there weren't a lot of people who knew about the experience and were able to help her make decisions about where to apply and all those considerations. So this tool is designed to help college counselors and help first generation students make that decision. So what we essentially created is a data trust. We've partnered with 4 organizations with data sets about first-generation college students. It's now one of the largest data sets on this subject in the country. And when students log into our application and they put in some of their information, then we can provide them with graduation rates and what colleges, based on those graduation rates, that are at their level. And then this is a tool that provides more information to these students. And traditionally, college counselors have been doing this kind of work, but it's very difficult. They have to cross-reference a lot of different sources, cross-reference those against their particular students' data points, and then that could take weeks or months. They might be developing heuristics that might easily become outdated as situations around the country change or situations at particular colleges change. It might not be for their heuristics might not be for the particular type of student they're working with. And so this is really a tool that is very fact-based and helping them make those decisions based on facts. So those were my remarks, and I'm really excited for our upcoming conversation to dive more deeply into the subject of AI for social good.
So the first question I'm going to pose to the panel is there a role for people in the technologies that you're building? Is it the case that your systems are fully automated and a lot of these jobs will go away? Or are the nature of these jobs changing in some interesting way? So we'll start with Anna.
Yeah, no, and I think there's definitely always going to be a role for humans in these systems. The role of AI in almost all cases is to either assist, augment, or help the person figure out how to get through their workload, do their job in a more efficient manner, in a more accurate manner potentially. So going back to, let's say, the healthcare example, if you have a radiologist and they're trying to determine if a scan has a potential tumor or not, you don't want to just sort of have an AI machine that says, oh yes, tumor. You want to be able to hand over the scan to the radiologist that has some markers on it that say, oh yeah, look at this area, maybe has some explanation of this is the reason that I think that this is tumorous or think that this is benign, and then have them, look through all that information and make the decision themselves. And this you can see over and over again in disaster response, in even in the hack harassment type of example where you're trying to determine hate speech online, almost all the systems that are out there currently and the ones that are going to be going forward, there are always going to be some ambiguous positions. Is this appropriate? Is this not appropriate? You might be able to call out some of the most inappropriate, but you are always going to have somebody in the loop that says yes or no.
As Anna said, the first thing I want to mention is that a lot of our tools are made to assist people, not replace people. And for example, in designing patrol routes for anti-poaching, we are kind of helping the site managers to at least provide a prediction of where are the areas have high poaching threats. And we also suggest a set of patrol routes and trying to reduce their cognitive burden when they try to design the patrol routes themselves. And in addition, I think a second role that human can play is when we design the AI systems, we need to work together with these human experts in the domain to develop something that is useful. Again, using the anti-poaching tool as an example, at the very beginning, we designed a tool that generates a set of patrol routes, and we send our patrol routes to our collaborators, asking them to send rangers to follow these routes to see how it goes. And then they came back to us saying that, oh, it's so unrealistic. The routes just looks like a straight line on the map, but if you check the kind of the terrain, it just, you cannot follow. And then we have to go back to our drawing board saying that, okay, we need to redesign our whole AI system. We need to check the elevation map and kind of build a virtual street map for the whole area so that the rangers can actually follow the patrol routes we provide. And that's kind of how AI researchers work together with human experts who are working in the domain to develop some AI systems that can really assist them.
So when you look at where the state of the technology is right now, Jason earlier talked about some of the qualities that AI systems do really well in. They're very consistent. They can take in a very large volume of data in a short amount of time and process that into something. They're very good at solving narrow problems. They're very scalable. So those are the kind of qualities you want to look for when you're putting in, an AI as part of a solution. But there are other qualities that they don't do very well in. They're not very flexible at solving more general problems or adapting to things that are unexpected when your assumptions change. If you need to have somebody interacting with a person and provide them, like a very personal connection in order to get them through something, having an automated system isn't going to do that 100%. And so definitely those are the kinds of things you want to pay attention to when you're thinking about how to design a system. Ultimately, AI is just one piece of any system that you design in order to do something, and there's so much of the rest of it in terms of how people interact with it, how those decisions are then being sent to somebody to act on. And so it's a pretty big problem, and those are all considerations you have to take in. And this is where it's really important to involve, like we've heard already, experts, design people, people who are experts in user research, to make sure that all of these things are fitting together into a product that will be successful. So definitely, at Uptake, most of our tools, like you've heard, are designed to help people make decisions. They're designed to augment people. Using the example of Student Union, which I was talking about earlier, we're not replacing college counselors. This is a tool that helps college counselors when they're working with students to make better decisions. And so, if there are areas where they're not making decisions consistently, or they're not able to take in a large amount of data in an efficient way, this is where it helps them with that piece of that process.
Yeah, so basically what reinforcement learning does is it is a type of deep learning. And what it is able to do is it's able to figure out like various states. So there's a similar thing called Markov decision processes, which is a slightly older form, which I also should probably describe. So I'll just basically say that you have an agent, for lack of a better term. And this agent is able to see, okay, let's say it's one of the typical tasks is like a learning how to walk or learning how to grasp. So this is used in robotics a lot. And that's one of the fields that is heavily used. And with the robotics, when it's learning how to grasp like this water bottle or something, it's okay, it knows its goal state. And it knows like where its current actuators are. So you're able to say, okay, I have this joint, and all these different degrees of freedom. And all of this is put into a model, or just, you have like a specific goal. And then what it's able to do is, over a lot of different repetitions, it's going to pick up the water bottle, and it's going to pick it up hundreds of thousands of times in a computer simulation. And then basically what you're able to do with that is your simulated robot now has learned how to grasp this water bottle, and it's able to do it pretty fast. Then what you can do is you can get an actual robotic arm and have it grasp the water bottle. And what researchers have found is that it's able to learn how to grasp it much faster than if it was just doing it without that like simulated environment. So does that?
Yeah.
Okay, cool. So some of the things that reinforcement learning is already really good at is some tasks like that. So they're fairly simple. There has been some in like completely walking. So this is used in robotics a lot. It's used in game simulations a bunch. So OpenAI has a platform called Gym. We have a platform called Coach, and they basically all have different learning to walk things like Atari, so Pong, things like that. Some things that they can be really good at would be like the wargaming, but that's a little bit more in its infancy. Like the problem with a lot of this is that you have to model everything. You have to model, okay, where are all the poachers? Where are all of our resources, et cetera? So it's complex. And for like this cucumber growing example and the autonomous greenhouse, it's also complex. So we have to model everything there so that it can learn. So it's definitely on the rise. It does have a ways to go for some things, and for other applications, it's pretty ready, and I believe it's being used in production in some instantiations like grasping.
So to jump in a little bit on that, from if you follow a lot of the research, especially a lot of the research is going into using reinforcement learning in video games, because it's a really interesting platform where they can play against professional players, and we've seen over the last few years in more and more games. I think not too long ago they had an AI system play professional players in League of Legends, and those professional players got absolutely crushed. And so, it's really interesting seeing the state of the technology and how far it's come. And one of the interesting things you'll see is that so the way these systems work, as you've heard a little bit, is you have a very high fidelity representation of the system, and you have a really good way of keeping score. So these systems learn how to play the game by trying things out and experimenting, and they figure out what things make their score go up and what things don't, right? So games are a really great environment for this because the way of keeping score is very well defined. There's very well defined win and loss scenarios. However, in the real world, and this is where I think data maturity of different organizations or different application scenarios is going to be a big thing, is, are you measuring that? Are you actually keeping score what you want? In a lot of real world scenarios, there might be some metric you care about, but you might not be able to measure it directly. You might have a proxy. If you have a proxy, then now you introduce risk of things like bias creeping in, of maybe your proxy doesn't quite measure the thing that you're interested in. It goes off a little bit sideways. And then when these systems are learning how to increase their score under the system, they might do things that are very unexpected, and things that in a real scenario where you might be dealing with people, there's a lot higher risk of that having a negative impact on people's lives. So I think that's where a lot of the things that people are still trying to figure out right now, that's where that's at.
Yeah, just one sentence. So I think reinforcement learning is helpful for problems where people need to make sequential decisions. And I think a rising research topic in this area is multi-agent reinforcement learning, where we always interact with other people when we make decisions. And that's where also game theory can be combined with reinforcement learning to solve some of the challenges.
Part of that is honestly on us. And so to make sure that we are explaining the algorithm in a way that is understandable by the end users, and a lot of that is working side by side as we're creating the workflow, as we're creating the solution. Because if we're giving you a tool that you can't understand, then it's not a good tool. Even if it gets perfect accuracy, even if it reduces the workload that any one given or any group of people has, then it's not a good tool. That said, the more you do understand about the data and the algorithm that's behind it, I think that can be useful. But yeah, a lot of it is one of the things that we're really trying to do, and a lot of researchers are doing this, is to try to increase the interpretability of these systems. Deep learning in particular has a reputation, which is somewhat justified, of being like a black box. You feed in a bunch of data with a bunch of labels, and it just is able to predict. And why was it saying that was a dog, or why was it saying that was a text that is inappropriate? So figuring out those ways of doing that is something that needs to be worked on more. But yeah, I think there's sort of both sides.
I think the training that is needed is probably some kind of general idea, or for the specific tool, when it would fail. What is the fail mode? That will be important when people interact with AI systems, and for that, interpretability would be an important criteria to so that the users know what to do, or can have a reasonable expectation of when it would work well. Yeah.
Yeah, I think they've really covered the main points. Boiling it down a little bit, I think the two biggest things are to support those is number one, the users have to be very familiar with the domain in which the system is operating. So they have to know about the data collection methods, know about how those things might trip up the system and when the system will be wrong. Also, I think a really good base skill for everybody to help them understand how these systems work is a better working knowledge of statistics. So, a lot of these methods have a lot of grounding in statistics. We're dealing with data and making decisions based on what we see in the data. We don't live in a world where everything's 100% black and white. There's going to be situations where things are wrong, or things, just from being random, don't follow exactly the pattern you expect. So having a knowledge of statistics will help a lot there.
Yeah, we're definitely getting closer. And before I was working on the AI for Good effort, I was researching natural language processing, so it's definitely an area that's near and dear to my heart. And some of the really interesting advances and innovations comes from something we call transfer learning. So basically what transfer learning, what you can do is you can feed in a bunch of textual information. And one of the really key things for a lot of these systems is like the more data that you have, the better. But a lot of times if you're doing like a conversational agent, you only have so much conversation. But what you can do is basically feed it all of Wikipedia, or you can feed it all of like the entire web scrape. And then it can basically learn how like text is formatted, how, like sentences work. And then you basically use that type of information and you feed it to your next model, which just is giving conversation information. One of the other key things that has been really helping with that too, though, is that more and more researchers, more and more organizations are creating these data sets and they're opening them to the public. They're opening them to other researchers, and that has really helped snowball.
So really, what the AI is good at doing is being consistent, right? And so, if you're providing it with a consistent framework, then that could be one way that you help, overcome human biases. But like you said, it's only as good as the data you have and what you're measuring. I think this is a really big area where transparency is a really important thing. Having transparency, then more people with eyes on it, you can identify problems where perhaps there are populations that your data isn't capturing correctly or not capturing at all. You hear about the term digital divide, where a lot of populations in the country and in the world aren't connected to all of these new digital services that a lot of us take for granted. And so those people are inherently not being represented in the data set. So it's a real danger. And I think, not just from the biases, but when we talk about using these systems to create decisions, we've heard about some examples where there might be limited resources. We're figuring out how to prioritize those, especially when you get into application areas like social services. You're making a decision about who is getting resources and who's not, right? And you can say, oh, AI systems, it's fair, it's unbiased, whatever, but baked into the design of that system is some set of values. And so the transparency is really important so that, as a society, we can all come together, discuss, what are the values that we want as a society, and making sure that the systems that we design reflect those values.
And I think to build upon that, there is like a lot of research that's being done in the field, which is lovely. And this is being done by collaborations between like research facilities, like so schools, as well as industry and the government, because it is such a keen issue. And it's interesting to see because in some instances you can sort of see the bias, you can measure it, and then you can mitigate it. So with natural language processing, for example, there's this idea of like word embeddings. So you can sort of have a space of saying, man is to king as woman is to queen. And so it's like learning that sort of gender. And so then you can say, okay, well, where should this gender bias, be relevant? Because, for that, that analogy makes sense. But if you do the same thing of like man is to computer scientist as woman is to homemaker, that's not so appropriate. And that algorithm actually still works. So like that's not something that you want to see in your thing. So I think anybody who is using that type of technology should be aware of it, should be making certain that they understand the latest mitigation processes and building them in, whether it's academia, government, or industry. Yeah.
I think human has bias and data also has bias, and it would be great if human and AI systems can work together, either through building AI systems that can reduce the bias, or just combining the human knowledge and the AI system together to kind of mitigate the bias in general. That would be great.
If I could also add one more quick thing. I think it sort of boils down to Kant or Bentham, which is, do you follow a specific process and you have rules that you're trying to follow, or is it the outcomes that matter more? And this is just sort of like a basic moral philosophy. It's not really clear which one's better, but we know which one's probably going to be easier, which is that, if you just check all these boxes, you follow all these things, you're done. But measuring the outcomes and showing that there's not bias there, that can also be really, really tough too. And as you also saw in the example I gave with livelihoods, that we might not even know if our data has bias. So, for example, one story I tell the students in my class is that there's one speech recognition engine that was trained only on Texans. And Texans have a twang, and so it didn't work for anybody else outside of Texas. But the people didn't realize that, and so there's also a process bias there, in that the engineers didn't realize they should have gotten other people, and so on. So it is a really tough issue. A lot of people are thinking about it, but the current state of the art is there's not great solutions yet, unfortunately.
This is also where, it's really important to bring in other disciplines, because ultimately the AI system isn't the full system, right? It's part of something else. So this is where you have to bring in designers. And I think, designers are going through a lot of thought and trying to figure out how to make these systems in any modern software system work better with people. So it's really important, I think, to bring people together and have a very holistic idea of how all of this works.
So from the AI's perspective, what we are trying to provide is that we design an algorithm that is general enough so that it can work for any type of input parameters, where here the input parameters are the payoff values. And indeed, there is a risk that when we apply this algorithm to a real setting, the input values provided by whoever user that is using the system would impact the result. And that's again why we need some kind of training to the users, so that they know what it is doing and when it would work well and when it doesn't work well. And it's not kind of completely in the control of AI researchers' hands to determine what to use. But of course, it will be a great research topic in terms of how to determine it. And for now, when we apply our systems for example, for anti-poaching, we are kind of using the reward being proportional to the estimated animal density. So it's, in that sense, yes, we are kind of, when we try to apply it, we do use some kind of easy to use criteria to determine it. But I want to emphasize that it is users' choice to determine what they want to use as payoff.
So I think with that, just to add on, I think this is a really key point where we want to have a collaboration with a multidisciplinary group. So people that are in the field with the people that are protecting against the poachers, people that are animal activists, as well as so the more diverse that you can get, the more assured, or yeah, I guess I'll say the more assured you can be that you're not going to bias based upon the output. So with this greenhouse simulation type of thing, we could say, okay, just grow the most cucumbers. This is our challenge. But we also, then you would just be pumping up the heat. You would be adding a lot of nutrients, things like that, and all of that takes resources. So instead, maybe we'll do a price, or figuring out like the right metric to use takes a lot of different people, and it's very important to do for sure.
Yeah, I think those points have hit everything. We're definitely going to encounter a lot of these situations where you don't have the data available to make a perfect system that you can 100% know is doing what you want, but having a system is still better than not having a system. And so, good intentions aren't enough. These tools can definitely be used incorrectly if people don't understand what the weaknesses are. So it takes a lot, and I think this is a really important area for policymakers, especially to be well educated and understand what we can do to mitigate any harmful outcomes from people misusing this technology, even if they have good intentions.
So I think if I understood it, so like if there's like, multiple companies and they're both trying to solve the same thing. So like, let's say tumor detection or whatever, and you only have so many funds, and, there are a lot of companies that are all trying to solve tumor detection, and they're each working with individual hospitals. So there's some good parts and there's some bad parts to this. For one, you might be like using more resources, like in terms of like manpower and monetarily, than you might necessarily do and if you had like just one group that was like looking at this. But the nice thing too is that one of the cool things in artificial intelligence in particular, like in this field, is that people are really interested in sharing their results and sharing their algorithms. So there's a very strong community of like papers. So like basically, if you don't write a paper about it, if you're not talking about it at a conference, you're not doing it, is the idea. So people are racing to publish, racing to talk about it. And then like if you're publishing, but you're not putting your code, your algorithms online for other people to see, then like people are hesitant about saying, oh yeah, you're actually doing this and this is a good solution. So people are also putting like their algorithms online. People are putting the data sets to the extent that they can. There's, especially in medical, there's all sorts of HIPAA type of restrictions that you don't want that information to be too shared. But that has really helped like researchers ping pong ideas off of each other. So like, even though these two industries, these two like, companies are doing things separately, they're learning from each other, which can be really helpful. So it's sort of like, metagame theory. It's like, who can get the most accuracy and how do we beat the other person, which can be powerful. Yeah.
Two quick points. One is I think the government agencies can invest more on these topics to avoid this kind of duplicated effort. Two is open source software is on the rise. Individual sectors, private sectors have already realized that sharing the effort and making it a standard for the whole industry is sometimes more beneficial to keep it than keep it secret.
Yeah, and in addition to open source software, open data is a really big thing that will determine success in collaborating on some of these things. Chicago's done a really great job, with their open data policy, and that's been able to support a very vibrant community of the public in Chicago. So I'm involved in a weekly civic technology meetup called Chi Hack Night. It's every Tuesday in Chicago. A lot of volunteers come together. There's always a speaker talking about some civic technology issue, anything from recidivism to recently the city's public health department talked about a program that they worked on to try to predict lead poisoning in infants, all sorts of things. And having that open data available, having a good ecosystem of open source software online allows a lot of these people who have a lot of technical skills to collaborate on projects like this. The city of Chicago has this really cool project they did a few years ago where the chief data officer of the city came to Chi Hack Night and he got data science volunteers, and together they helped create a model to predict E. coli levels at the public beaches in Chicago. The lab tests take a day, and by the time the E. coli levels are elevated, it's too late to warn people at the beach. And so, some of the existing models weren't doing very well. And so, they worked on a project that was able to help them improve their ability to warn beachgoers about elevated E. coli levels. And that was done in large part through help from volunteers from, the civic technology community in Chicago.
One quick thing to add a little bit more context too, the demand for people with AI and machine learning skills is incredibly high. There was a news article in the New York Times suggesting that some of these people are being paid like $400,000 to $1 million total package. It's crazy. I'm not going to ask these folks if they're paid. But the other thing too is that people want to work with these other really smart people, and they also want to publish these scientific papers because it's also prestige within the community. And that sort of leads to the openness and building on top of each other and leading to this kind of positive kind of win-win competition. So that's sort of the current context of things, which is leading to a lot of the positive open sharing and other kinds of behaviors that are going on.
There's some difficulties with that because, for one, like, all this information is quite protected. Like, if NECMEC, basically they get conversations from social media from other organizations that they have then flagged that says, like, this conversation that's going along between these individuals seems like it could lead to a situation where this child could be abducted, could be being trafficked, could be like sexually abused or harassed, things like that. And so we've done a couple of projects with NECMEC, and one of them is to try to call to NECMEC's attention, like, those conversations that for those children who are most at risk. And that is something that is difficult for AI as well as for humans to understand in particular. And, it goes back to, like, how do computers understand textual, like, NLP type of things? But, it is an area that is, being looked at and addressed, for one. And you're right, a lot of times it's not discussed as much in the public eye. And part of it is because, people don't really want to hear that this is going on, that, this is a problem. And it's, for a lot of, industries, for a lot of groups, like, if they say, oh yeah, we're trying to fight children trafficking, or like trying to fight, sexual abuse, those are really hard things to say in a public setting, because for some it could be triggering, for some it could be, I don't want to look at that. But no, I don't know if that quite addresses your question, but I agree that it's definitely something that we need to keep on looking at and keep on trying to help, because, if you have a person who's just going over these texts day after day after day, that's a hard job, and that's something that AI can help them, like, look at less of these texts. So, no.
Okay, so let's go on to the final question. So my final question for the panel is, if you had one takeaway message for policymakers, what would it be? So Jay, let's start with you.
Sure. So I think it's come up a little. We've talked about data maturity, how organizations doing any kind of solution has to think about their data capture systems, about the skills to understand and support and maintain these systems. And in addition to that, I think, like, really understanding how they work and being able to communicate that, and transparency is a really big thing. There in the last few years, there's been a lot of writing around how automated systems or AI systems have underperformed or done harm, or the systems have failed. So, an article that I think a lot of people know about is ProPublica's machine bias article about the recidivism model, and how there might be bias in that based on their analysis. A few other books, so Weapons of Math Destruction by Cathy O'Neill, and then another recent one from this year, Automating Inequality by Virginia Eubanks. So, with those two books, they talk about a lot of really great examples of how some of these systems have had shortcomings or failings. I don't 100% agree with all their interpretations, but I think it's really important to have that conversation started. It takes, I think, everybody to look at these systems, how they're designed, making sure that they align with our values as a society. And so I think transparency is a key aspect in that, and that's where I think policymakers have a really large role to play.
I think the message that I want to mention is, first of all, AI can really help address societal challenges in various ways, and it can deliver benefit to the society now or in the very near future. And at the same time, for some of the domains, it's kind of hard, at least for AI researchers, to get funding because it's not commercializable. And I hope that there will be more government funding available to these domains for both the basic research and the applied research.
Yeah, and I would just say, like, continual interest is lovely, and, you know, learning more about, you know, what are the projects that could help, reaching out to academia, reaching out to industries and saying, you know, like, I have this issue and I could really use some help with this. Is this somewhere that we can really collaborate? Is this something that we could get help on? Is this something, you know, where AI could fit? Because the answer could be yes. The answer could be, oh, well, you know, like, come back in a couple months or a couple of years, and then we can, like, figure out a solution from there. But I think, you know, like, a shorter term type of thing also is more open data. So, like, one of the things that can really help us is, like, learning from, like, different, like, data sets, different types of use cases, because, like, if, you know, like, we're trying to look at, like, manufacturing, or if we're trying to look at types of networks, like, getting data from, like, the FAA or getting data from, like, other government sources can be really super helpful. So open data access can be key for that. But yeah, interest is great, and yeah, I'm super excited that there were so many people here today talking about this issue.
So last thing I'll say too is statistical machine learning, which is the dominant form of machine learning today, was really esoteric in the 1990s. The deep learning, which is these neural networks, they were invented in the 50s. It took over 50 plus years for these neural networks to finally start working, and now they are dominating and beating the pants off of everything right now. And so what I would say is that we really need lots more long-term thinking and more sustained investment into these things. Just as a reminder, everyone, Google was based off of a National Science Foundation grant that was less than $3 million. It's paid for itself multiple times, many times over, and we need more things like that. Okay, so that's my soapbox. Thank you very much. We'll be here for the rest of the half hour, and happy to chat with you guys. Thank you.